My name is Mohit, and I'm going to be talking about first the broader UMass NLP community and the four faculty that make up UMass Natural Language Processing. And afterwards, I'm going to talk about what each student in my lab is doing to give you a broad overview of my research interests. So UMass NLP is made up of four core faculty, the ones listed here. So myself, Lori Thompson, Brendan O'Connor, and Andrew McCallum. So I'm going to start by giving a quick overview of each core faculty's research interests, and then we'll move on to more specific stuff about my lab. All right. So Lori is our most junior faculty. She started in 2020, and she's also the most interdisciplinary of all of the four faculty members here. Her work is mainly at the intersection of computational humanities and NLP. So a lot of her work focuses on interpretability, so trying to understand what some of the NLP models that people are using today, and also NLP models that are commonly used in other fields. So for example, topic models are extremely popular tools for humanists to understand large data sets of text. And lately we have things like word vectors and pre-trained language models, which offer more powerful insights potentially of these corpora. So it's important to know what kinds of aspects of the text these models are latching onto, and how can you actually direct them to learn certain properties that you care about. So a lot of Lori's work is in combination with faculty in other fields, so like literature, history, and so on, and trying to help their research by applying NLP tools. So some of the specific applications that Lori works on are things like science or speculative fiction, and also she does some stuff with images in text. So regarding archaeology, she works on large data sets of ancient gems and pictures of these gems, and trying to help analyze the text written on them, or even features of the images themselves. So yeah, that's a summary of her research. The next faculty we'll cover is Brendan. So Brendan started in 2014. He just recently got tenure, and his lab is called the Slang Lab. So they mainly focus on computational social science and NLP applications to this area. So Brandon's lab specifically is looking at the intersection of social factors like race and gender and location, and how such factors affect our NLP models and data sets. And there's also the reverse question about how you can use NLP to learn more about society at large. So a couple of the projects that his lab has already done include tracking police fatalities from news reports, measuring racial disparities in existing NLP tools, so like language identification systems or part of speech tagging systems. He also has many other projects going on, so computational linguistics of African American English, a lot of like event tracking and entity-centric NLP. Brandon and I are working together on a co-reference data set collection project with many different domains included, and some of his work also interfaces with HCI. So like, how do you visualize important events and timelines in a huge collection of news data? So we also have Andrew McCallum, who's the most senior member of UMass NLP, joined in 2002, and his research is mainly at the intersection of machine learning and NLP. So some of his current research focuses are on representation learning of hierarchical data. And I'll talk a little bit more about that since we co-advise a student who's working on this. He also does a ton of work on knowledge graph construction and reasoning over knowledge graphs. So answering questions conditioned on the fact that you have access to a huge knowledge graph. Lately, it's been more how do you leverage these large scale pre-trained language models to do better on knowledge graph reasoning or construction. And some of his other interests include just more efficient and accurate low-level NLP. So these are tasks like named entity recognition or relation extraction, which are very important practically speaking. On the machine learning side, he has a focus on huge scale clustering problems, and also his lab recently developed structured prediction energy networks, and they're doing some more follow-up work on that. So yeah, throughout the course of this event, you will likely meet many students and also these faculty that I've just mentioned who work on these different things. But the purpose of this was just to give a broad overview of what the other faculty in the UMass NLP lab are working on. So before I move on to my lab, I just wanted to say that we are highly collaborative. So Andrew and I, for example, co-advise a student who's working on unsupervised structure induction. Lori and I have been collaborating on one of the projects that I'll describe later on. And Brendan and I have worked together on many different projects at the intersection of computational social science and NLP. So a lot of all of our students sit in the same lab space. So there's a lot of cross communication between labs. And we do things like social events and other things like that together. So it's a pretty closely knit lab. All right, so moving on to my own lab, which is supposed to be the focus of this talk. What I wanted to do is, so in broadly, my lab works on problems related to text generation, but there's also a bunch of other stuff that we work on that's not exactly related. So I have currently 7 PhD students and 1 postdoc. So I thought it would be nice if I just went through each one individually, listed what they were working on and what their past projects were, to give you an idea of the different sorts of research interests that our lab has. So we'll start with Nader. So Nader is a 4th year PhD student. He was part of my first batch of students. And he actually spent like a decade working in the video game industry before joining UMass as a PhD student. His research interests are in story generation, generating dialogue in interactive settings. Hopefully, eventually we'll get to a point where we can actually integrate some of these models into video games. But I wanted to highlight one of his past works, which was on integrating language models into an online story writing platform. So you can check out this URL if you're interested more, but basically there's an online community of writers, and we wanted to offer help from a model if they're stuck with writer's block, for example, to get some inspiration for new ideas on how to continue their story. We also wanted to measure how do actual authors interact with the output from a language model, which is generally not going to be perfect or even close to perfect. Honestly, it's a good sign if it's at all relevant to the input story. But we found some interesting results. Basically, human authors do not actually find language model output useful for the most part. And the most use they get out of it is for very low level things, like if they need to come up with a new name for a character. That's actually quite difficult for authors to just come up with names of characters. Language models just routinely hallucinate names, so they found that useful. We were kind of disappointed because we were hoping, there would actually be some ideas or plot lines that the model generates that are useful, but the models aren't there yet. Anyway, we've created this benchmark, and hopefully when models improve, we'll see more utility to writing assistance agents. Currently, Nader has kind of switched from story generation to dialogue, paraphrasing, or generation for non-player characters in video games. So we're trying to build a mod for an existing video game where some of the dialogue is automatically generated and get player feedback on whether this is improving the experience or not. All right, so the next student I'll be talking about is Andrew Drozdov, who's also a fourth year PhD student. He is co-advised by myself and Andrew McCallum, and his work primarily focuses on inducing syntactic tree structure from language without any supervision. So if you have some familiarity with natural language processing, you've probably heard of the task of parsing, where you take a sentence and you extract some sort of tree structure that defines the sentence, the sentence's syntax. So for example, there's like a noun phrase and a verb phrase that combine together to make a sentence. And usually these parsers are supervised. So you need to have some linguists label a large data set of sentences first, and then you can train your parser to extract these trees. However, we are interested in the unsupervised case, where if you don't actually have access to the labeled trees, can you still extract some sort of syntactic structure from a model? And if so, what does that actually tell us about what these models are learning about language? So Andrew has developed a class of methods. Broadly, we've been calling this Diora, which use some of the traditional chart parsing algorithms, but kind of integrate those with the latest neural network modeling of language to extract these trees. And there's a whole line of applications for this that he's also worked on. All right, next, I'll talk about my postdoc's work. So Margena is a postdoc who joined almost 2 years ago now, and she's very interested in crowdsourcing and evaluation of text generation systems. So her previous work focused on a widely used way of evaluating text generation models, which is crowdsourced evaluation. So basically your model spits out some generated sentences, you put them on Amazon Mechanical Turk, and you ask a bunch of workers to rate the output on various properties like relevance or grammar or coherence. Margena found that none of these evaluations is reliable, despite the fact that almost all NLP generation papers do this kind of evaluation, and they say, oh, my system is better than this other system because human raters thought the outputs were better. The ratings vary considerably by like day of the week or by the country of origin of the workers or so on. And so we need to be very careful when we're working with this kind of data and getting these evaluations. So she suggested a bunch of ways of improving these kinds of evaluations. All right, so moving on, my student Colpache is interested in controllable text generation. So he has worked on tasks like long form question answering, where you might get a question like, why do humans need to eat many kinds of foods, but cows only need to eat grass? And first, you have to retrieve a bunch of documents that could help you in generating an answer to this question. So you might retrieve like the Wikipedia article about cow and human digestive systems. Then you need to kind of summarize and simplify all that information into a paragraph-long answer. So this is kind of a retrieval augmented text generation problem. We found, first we developed like a state-of-the-art model for this task, but then we found that the evaluations are not reliable, so it's hard to say if our model is doing anything better than any other model. He's also worked on style transfer. So like given a Twitter sentence, like, I don't know, I don't want to cause no drama. Can you transfer the style into something like Shakespearean style or something else? So he's done some work on that. Just a couple more to go here. So Simone is one of my students focused on improving transformer architectures for language modeling and machine translation. She's done a lot of analysis work showing that transformers are important, but simple architectures can be competitive with them on the task of language modeling. She's also discovered that architectures that are designed to use long range context, so like thousands of words of context to predict the next word, don't actually use that context. So people should rethink how they present their papers and motivate them. She's currently working on building long range language models that actually learn like discourse representations from huge contexts. So like 10 or 20,000 tokens, can you build a long range language model that efficiently uses that context? Catherine is my most junior student, and she works at the intersection of like computational literary analysis and NLP. So her previous work, which will be appearing at ACL this year, basically is about given an excerpt of scholarly analysis about a book like Pride and Prejudice we have over here, where they quote a sentence from Pride and Prejudice. Can you train a retrieval model to, given that same context without the quote, retrieve the actual quote from Pride and Prejudice that is relevant to this context? So she created a big data set and trained some retriever models to do this. And now she's currently working on using literary translations to explore the task of document level machine translation. And my student 2 has been working on few-shot learning and transferability of tasks with different NLP tasks. So he developed a method called Strata, which with only 8 labeled examples is competitive with a model that's been trained on 27,000 examples. And he's further improving this method in his latest projects, also branching out to different tasks. But yeah, has been pretty much focused on these kinds of few-shot learning problems, which are important, right? Because it's hard to get a huge data set of labeled examples for every task. Finally, my student Chufan has been working on neural topic models and learning phrase representations like dense vectors that represent phrases. He had this recent paper called Phrase BERT, where we used a contrastive objective to learn meaningful semantic representations of phrases. So for example, this phrase, the jack of all trades, it does not, it shouldn't be relevant to a phrase like agreement on trade, right? Jack of all trades is an idiomatic phrase, but in a normal vector space model, you would see a lot of similarity between these two phrases instead of something like a worker with versatile skills, which is actually what you would want the similarity to be like. So he devised a model that kind of fixes this problem and now is currently working on extensions of this to retrieval augmented language models.